Hello and welcome to another video. In this video we're going to be working on subarray product less than k. And in this problem you're given an array of integers nums in an integer k and you want to return the number of contiguous subarrays where the product of all the elements in the subarray is strictly less than k. So in this first example they show you all the subarrays and 10, 5, 2 is not included because the product's 100, so you have to have less than k, not less than or equal to. And in the second example, k is 0 and all the numbers are 1 or higher, so there are no subarrays. So let's take a look at this example, and this will explain how to do it. So one thing we could do is we could have an n cubed solution, which would be really bad, right? So we could just say okay, let's just pick for every single start index and every single end index. Let's say this. Let's get the product of the subarray. And then if that product works, then we will return, or we will add one to the result. But notice that, let's say we have a subarray like this, we have a product, and now we go from that subarray to this. All we just did was have our old product, and we just added one more value. So we can condense that down to an n squared solution. So we could say, for every start index, let's go, let's delete this really quick. So let's say this and this. We could say okay, for this start index, let's just keep making the subarray bigger and bigger and bigger, and every single successful one we will increment our result. So here subarray is product 10, so that's 1. Then we can do this, so it's 50, which is another one, and then this is 100, which is too big. So now for this start index, this doesn't work, and then obviously everything bigger won't work. Same thing here, this will work, so we would add 1. And then we would extend it, so our product is 10, so add another 1. And then we would extend it again, so our product is 60, so add another 1. And now this is too big, so we just stop there. And we do this for every start index. So for every start index, we just keep growing it until it's too big. And that would be n squared. But the thing that we can do is, to make this faster, is if we just know, given the start index or end index, let's just say let's get the biggest subarray we can that ends with some index, like this index over here. So for this, the biggest subarray we can that ends with here, we can grow it out this way. So this is 24, 48, so it's going to be this one over here. And if this is the biggest one that ends with this index, how many subarrays are there total that end with this index over here that we can build? That, if our k is 100, how many subarrays are there that we could do that with? So there's this one, then there's this one, then there's this one. So we can write this down. So given an end index, if we know the length of the biggest array that can end with this, then the number of subarrays that end with this is the length of the array. And that's kind of the trick to solving this problem. So if we know that this is the biggest array that ends with this, then we know that there's 3 subarrays that end with this, because there's this one, there's this one, there's this one, right? So if the subarray is length 5, we can have the whole thing, the whole array minus 1, and so on. Let's say this whole subarray, for whatever k we were trying to get, let's say this was valid. So we got a subarray that ends with this index. So, well, that's 1, that's 1, that's 1, that's 1, that's 1, and that's 1. So because the length is 6, there's 6. And we can use that, so we can use this to have a sliding window solution. And our sliding window solution will just grow. For every start index, or for every end index, we will keep making our subarray bigger, and then we can shrink it if we need to, and then we can, in O of 1, figure out, for the subarray ending at this index, how many, for our window ending at this index, how many subarrays are there. So let's walk through that one. So we'll say k is 100, and let's start here. So we'll have 2 pointers. And we'll keep track of a product. So the easiest way for the product, just have we can keep track of our product, and we want the product to start at 1. We don't want it to be at 0, because we're going to multiply it by where we currently are. And there are no zeros in here, so we'll just have our product be 1. So we'll say it's 1, and then our result will be 0 to start off with, like how many subarrays we have. So here, our product is 10. And this is less than k. So given this end index, because there can only be one number for the subarray ending here, right? It's going from left to right. So there's only one subarray that ends at 10. So we will have 1. Then we grow to the right. So now our thing is 50, our product. And how many subarrays are there now that end with 5? Well, it's whatever the length of this thing is. So that's 2. So we have 1 plus 2. Then we try to grow out again, and now our product is 100, and so it's too big. So we have to shrink it. So we will shrink it, and shrink pretty straightforward. You just divide by your left. So if we shrink it, our product here is now 10. And so how many subarrays are there that end with this? There are 2, and just to quickly show you once again, so there's this one, and then there's this one. And that's kind of the idea. The length of your window is how many subarrays there are that end with this current location. So we'll add 2 more. And then we will grow. So now we have 60. And how many subarrays are there that end with 6? Well, the length is 3, so we will add 3. And notice that would have been the result for the original problem, the 10526. That would have been 8. But let's keep going. So here we have 60 times 4, which is 240. So too big. So we will shrink. 240 divided by 5 is 48. So 48 is fine. So how many subarrays are there? There's 3. And once again, it's this, and this, and this. And then finally, we will multiply by 9. So 48 times 9 is 360, and then let's see, bad at math. 360 plus 72, so it's 432, I think. Doesn't really matter, like, if we don't get the right thing, but it's fine. I think it's this. Maybe I'm off a little bit. So this is too big. So we will divide by 2. So we'll get 216. And you shouldn't have a product, or you shouldn't have a problem dividing, because you're dividing by numbers that you multiplied your result by already. So you should never have like a remainder or anything. And this is still too big. So we have to divide this by 6. So I think this is like 36. So we get 36. And now we shrink again. So now for this, there are 2 subarrays. So for every index, we figured out how many subarrays there were, and then we just add all this up together. So this is 5 plus 6, 11, 13. And so we have 13 subarrays. So we have 13 total subarrays that the product of them is 100. And that's basically all you need to know for this problem is for every end index, just figure out like what's the biggest subarray that I can have that includes this. And then the number of subarrays that I can have that includes this particular end index is just the length of that window. And yeah, so let's code that up in Java. So first we can say if k equals 0, we can just return 0. So we can say if k equals 0, let's just return 0 because there's never going to be anything there. Now let's handle our other things. So we need a result. We need a current product. Make that 1, and we need a left side of the window. Now we do the normal window, so this is just like very common now. So r equals 0, r is less than num's length. And what we need to do is, so there's another case here that we don't want to just like grow and shrink our window. We can do a little shortcut. So let's say k is like 4 and our number is 6. If our number is bigger than k, then we can basically, like, this will give us 0 numbers. So, like, if k was 4 and we're here, we can just be like, okay, well, anything here, like, any window here is not going to be valid that includes a 6. So we can just skip this number and then make the left the next number. So that's what we're going to do. So we're going to say if, it's not tabbed correctly, I think. Yeah, so we can say if num's right is greater than or equal to k as well, we will just skip this iteration of the loop. So we'll say left equals right plus 1, and we can make our product, we can reset our product because there's nothing that's going to work here. And we can just continue. Okay, now is our actual thing if our number isn't too big, so then we can say product multiplied by nums right. And then what we need to do here is we need to shrink our window if it needs to be shrunk. So while product greater or equal to k, and now that we know that our current number is less than k, we don't have to worry about like getting rid of the whole window. So at the very worst, this number will be able to be used. So now this is just the opposite. So product divided by nums left, and we want to increment nums left here. So there we go. And then we just return result. So let's give that a go. So I clearly did something wrong here. Let's take a look. So 10526 is like one of the original inputs, I think. Yeah. So let's see. Product times equals. This is fine. So if nums right is greater than or equal to k, then left is r plus 1, which is fine. It's like the next index, so that part's fine. Product equals 1 and continue. Oh, we never update our result, right? That's right. So our result needs to add the length of the current array, which is just the standard right minus left plus 1. So that's what we forgot. There you go. Nice. 4 ms beats 100. I think I had 5 ms last time. That beats no one. Good old Java. Okay. Yeah. So the time standard sliding window space. So 1. And what I would recommend for these problems, so you can just quickly look at the constraints and know that like n squared is going to fail if num's length is 10 to the 4th. I think something like over 10 to the 7th fails. And also, if you're looking for contiguous, like anything contiguous in an array, the number one thing you should look for is a sliding window. So like figure out what the brute force kind of needs to look like, and then how do I make that into a sliding window? By either doing like every end index or every start index or some trick to get that down to O of n. Because almost all problems that ask for, or quite a lot of problems that ask for, a contiguous chunk of your array is going to be a sliding window, because that's what it's for. And then if it's not contiguous, if it's like subsequence with elements removed, then go for DP is like the number one thing I would look for. So yeah, just wanted to mention that. And yeah, I think that's going to be all for this one. So hopefully you liked it. And if you did, please like the video and subscribe to the channel. And I'll see you next one. Thanks for watching.